Hello and welcome to Builders, the podcast where we explore the stories of innovators shaping the future of technology. Today we have a truly exciting guest, Gilles Backhus, co-founder and VP of AI at Recogni. Recogni is pioneering energy-efficient AI computation for autonomous vehicles and beyond, tackling one of the biggest challenges in AI today, delivering high-performance computing without excessive power consumption. Gilles has played a key role in shaping Recogni's vision, leading global teams across the US and Munich, Germany, and driving innovation in AI hardware and software. Today we'll dive into Recogni's groundbreaking technology, the challenges of scaling a global AI company, and what the future holds for AI-powered industries. Gilles, a warm welcome to Builders. How's it going?
Hey, thanks, Lee. Yeah, great being here. Thank you for having me.
Thanks so much for joining, and we've got quite a lot to talk about, to go through. But let's start, shall we, with if you could give us a brief overview of your background, what led to Recogni, what you were doing before, what was the inspiration?
Yeah, absolutely. So I come from electrical engineering, and I actually, since I was a kid, I always wanted to work on computer chips. And that never left me. And then I did my studies. I also attended CDTM, which is this other program where a lot of founders come out of. And with a couple of coincidences here and there, because I did my master thesis in Silicon Valley, where I got to know my co-founder. Recogni happened 7.5 years ago. We started the company with the goal of developing very energy efficient and very fast AI chips. And we're still at it. That's kind of my background. Yeah.
Nice. And I pronounced it Recogni in the beginning, so Recogni. Apologies for that.
Recogni, yeah.
And Recogni's a slogan: "We exist to accelerate the world's AI ambitions." I've seen. Tell us more about this.
Right. So, I mean, obviously, this statement has kind of a bit of a generic nature to it, right? That, whatever AI workload you have, we want to be the ones accelerating that in the best way, at the biggest scale, at the lowest power consumption, at the best per user speeds, at the lowest cost. And we've had a past where we were rather focused on, one market, but we completely left that, and we're now very focused on AI in the data center. Of course, in data centers, there's lots of stuff going on, right? Most people nowadays talk about Gen AI, but it's about more than just generative AI. Generative AI meaning that models are basically creating human-like content. Now we're also getting into agents, but even if you still have a good old convolutional neural network, we can still accelerate that. So we really try to design our second generation in a way that it's fairly agnostic to the AI workload that you have, but it is otherwise absolutely optimized for AI workloads.
Yeah. And talking about Recogni's and what the future of this kind of energy efficient AI computation, obviously, I mean, AI computation is the backbone of modern artificial intelligence. What enables machines to process the vast amounts of data and make these decisions in real time, right? AI-driven industries today, they're demanding these more power-efficient AI models, right? Can you explain what makes Recogni's approach unique in tackling this challenge?
The challenge of power consumption? Yeah. So we have developed a different way to do math. So an AI model essentially is one giant formula. It's really nothing else. So whether it's your ChatGPT or an image generator or a video generator or an agent, yes, there's also a couple of let's say more programmatic things in there where you have an if-else statement or a for loop or whatever. But 99.99% of the actual compute of the big workload that you have to crunch through is just math. So math is multiplications and additions, essentially. And so what AI models, whatever the flavor is, are constantly doing is A times B and then plus C. A times B is very expensive in hardware, or generally expensive. So it's quadratically more expensive than adding two numbers. So multiplications, as they're so expensive, we try to find a way to eliminate multiplication from our chip and thereby cut down the power by a lot. And it sounds a bit like magic, obviously, but it boils down to so-called logarithmic math. The simple rule that a lot of us might remember from school is the logarithm of a times b equals to the logarithm of a plus the logarithm of b. And that basically means if you have the two numbers that you want to multiply, if you have them in memory in their logarithmic form, you can just add them in that form, and effectively in the normal linear space, you will have successfully done a multiplication. So suddenly a multiplication became an addition. And now the question is, now how do I tackle the original addition? Because that also needs to be computed. And that's where basically the secret sauce of our innovations and the research that we've done over the last 7 years comes in. There's a lot of details to it, obviously, also how to make this very efficient circuits on a chip. But effectively, that's what massively brings down the power consumption in an AI chip. Yeah.
Okay, got you. So traditional AI processing relies heavily on multiplications. Right. They are in themselves computationally intensive, consuming significant power, and what you're doing is kind of transforming those into additions and thereby kind of reducing computational complexity. Right. Have I got it right?
Yeah, pretty much, yeah.
Nice. Talking about this kind of computational intensity and everything, there are obviously kind of growing concerns about AI's carbon footprint, right? Do you think the industry is doing enough to address this kind of sustainability and kind of AI computing?
Mm-hmm. So the carbon footprint of AI on a global scale today is actually not that big, right? I think it's around 1%, roughly, like 1-2%. It's really not that crazy. There have been a few headlines that have also been, I guess, debunked should be the word, or analyzed again, and people were able to show no, it actually didn't cause that much CO2 to train that one model, and so on. Things are becoming more efficient, but if you're really honest, right, like the big corporations that are trying to make things more efficient, they're not doing it because they want to save the environment, even if that's what they might say, and they have to say it, but in today's world, but they're doing it to save money, right? They're doing it to scale to even better models to win the race, right? It's a race right now that's going on. And if the side effect of all of this is that we're saving the environment and we're actually not, pumping out so much CO2, then great. Obviously, that's a very good secondary effect of it. But yeah, the best way to make things more, I guess, cheaper, right, is to basically get more compute out of the same kilowatt hours that you've put into that system. And yeah, certainly companies like us are working hard on reducing that quite massively. There's a bunch of other companies that are trying to bring down the power consumption continuously. Every company from generation to the next generation is bringing down the power consumption effectively. But it's also a little bit like that paradox, right? Where if you make things cheaper, the people will come and actually make more use out of it, right? So it'll always stay at that same level.
Yeah.
If we're talking about some crazy future scenarios where every person on the planet gets individualized education through an AI model, right? And like imagine I would be an AI model right now, 100% every pixel is generated by an AI model. Once we get to that kind of level, yes, we're really talking about 10xing, if not 100xing, the current global electrical power consumption. Now, that of course would be that's a problem. That's a huge infrastructural problem that we certainly cannot solve today, and that's going to come from more and more from generations and generations of more and more efficient systems. So, to answer your question, is the industry doing enough? I think they're forced to do something. Is it enough? I would say if you really boil it down to why they're doing it, you could argue they're not doing enough, or they're not doing it for that purpose. Yeah.
No, but, right.
Yeah. So that's my take on it. Yeah.
Yeah. No, I think it's a good point. They're not necessarily doing it for that purpose, but it might be a secondary effect, and that will have that kind of positive impact. And yeah, so tell us a bit about Recognize approach. You're operating in two major markets, right? Locations, so Germany and the US. Is that right?
That's where our offices are set up. Otherwise, we're fairly. I mean, yes, surely, mostly it's Europe and the US, or North America and Europe, where we focus also from a business point of view. But yes, we have two offices: one in Silicon Valley, San Jose, and then one in Munich, in Germany. Yeah. And so I can tell you more about the company.
Please.
So we're a little over 100 people, 110 people, I think, at the moment. We're split more or less 50-50 across Germany and the US. And we're mostly developers. We're very much in execution mode. So it's a very engineering heavy organization. Even the people in non-engineering disciplines also have an engineering background, at least most of them.
Nice.
So it's, we're in many ways, we're pretty classic Silicon Valley startup that also has a very major, second headquarter, if you will, in Munich. Because the AI talent that we were able to get in Munich is amazing. Actually, it's tremendous team out there. Also, tremendous team out there in San Jose, and it's kind of this synergy of different engineering cultures, right? We have Silicon Valley with very experienced chip designers who have gone partially through 20 chip generations in their lives, super experienced, very smart, very experienced people. And then you have a much younger team, of course, of AI developers in Munich. And together, right, I mean, people always talk about hardware, software, co-design. So together we're developing chips essentially, and systems and software. And we're 7.5 years old. We're pretty traditionally venture funded, I would say. And I don't know if there's anything else to say about it. Yeah, focusing on AI inference. We're not focused on AI training. No. That's about it.
Nice. And there was a fairly recent partnership, right? Was it Juniper Networks?
Right, Juniper Networks. Yeah.
Was this late last year? I saw.
Right. We announced it not too long ago, exactly. And Juniper Networks is actually the world's pioneer and inventor of some of the most important networking technologies that people are relying on these days in AI compute. It's absolutely phenomenal to work with them, because it really, checks the box of networking, right? AI compute is not just about how do I, compute things most efficiently and how do I take care of the math. It's also a lot about networking for multiple reasons. In inference, the most important networking aspect is how do I connect a lot of chips together into one very fast network? Because if the more chips I can connect into one network, and the faster that network is, the better I can take a huge model like a DeepSeek R1 or Llama 4.5b, or some non-open source models like a O3 or like a GPT-4, and parallelize it over so many chips, so that even though the model is very big and would normally take a lot of time to react to a large input and so on, I can now almost linearly, with a number of chips, bring down the compute time. And so for the end user, it's a much better user experience, because I get my answers much more quickly back after hitting enter. And the same is true also for media generation, for image generation, for video generation. It's very exciting, because I think it's fair to say that our system will be the first one that can generate 4K video, or at least very high resolution video at a fairly high frame rate in real time. And that's again because we can parallelize models over many, many chips. So it's log math, right? It's a Pareto log math that brings down the power consumption, and it's also the networking between chips that really make this such a dense and efficient system.
Really, really interesting. So you've been scaling a team in let's face it, a really, really highly competitive market, right? Not just engineers, AI engineers, and everything. What are the core traits that that you look for when you're hiring team members? I mean, specifically for the AI and engineering roles.
Yeah. So I can talk much more about the hiring we did in Munich, in the Munich office, because that's the office that I kind of built in the first many years. I can talk less about hiring in Silicon Valley. So about Munich, talent and the kind of talent that you want to hire there and how to do it. I think we went through a couple of phases. In in the very important early days, so let's say 2019, 2021, maybe 22, here's how we basically hired the amazing team, of which most people, we actually have extremely low attrition, which might be one of the things I'm the most proud of in having built this company.
Nice.
How did we hire them? So first, we were lucky enough to work with an amazing recruiter who just happened to find me. I was actually, I think, his first client after he became self-employed and he started his own little shop. He was amazing in just finding people. And he was amazing at approaching people cold on LinkedIn, and then we had a really good hiring process where we didn't just focus on really, testing the candidate very deeply. And I think it's fair to say that we had one of the hardest interviewing processes, maybe in Germany, let's say, for AI talent. And we also custom tailored it to AI talent quite early on. But besides the technical talent, before Recognize, I've been in a couple of startups where the tech talent was amazing, like super smart people and just, phenomenal brains and minds. But there was not a culture because the people, right? Like, how do you be like, what maximizes the likelihood that you become friends with someone at work? First, let's talk about what the beneficial effect of that is. When you become friends with someone at work, communication gets better. Communication becomes more proactive. People might stay a little bit longer in the office because they like the other person. Meetings are healthier because, there's respect and so on. There's more fun, right? Fun is always great for keeping people for a long time loyal to a company. So it really helps, right? And also for us as an employer, if we know there's friends, right? I know it sounds a bit horrible, but it's also just less likely that they're going to leave us, right? Because they don't want to leave their friends, right? So, which is a bit of a selfish view as an employer, maybe, but it's also great for the employees. And,
exactly, it's a win-win, right?
Yeah, it's a win-win. Yeah, it's a classic win-win. But the likelihood of people becoming friends, right? It's when they actually have something in common, right? So what I've seen in other startups where I've worked at is, there's a few proxies, right? That you can test even yourself as an employee. Like, am I in an environment that has what I just described, right? And I've been in other companies where I felt like I'm so much looking forward to every lunch break every day because I know it's going to be so much fun. We're going to talk about, funny topics, going to crack some jokes, and it's just going to be awesome. And then there were companies where I was like, oh God, I don't want to go to lunch. I just want to have my own lunch at my own desk. And I know it's going to be boring again and kind of awkward. And there's not, and so what I really tried very hard was to hire people where I could always tell that, besides their technical abilities, they're showing some traits where I'm like, okay, this fits the culture, right? And then as we were expanding the team, always trying to make sure it still fits. And if you would see all of the people in the Munich office, you wouldn't at first say, oh, they all look like super similar tech bros, like they all look the same. No, not at all, actually. It's a very diverse bunch. But just from a character point of view, yeah, I think we really made a good job in finding people who can click together and work together. And this, I think this is what made it work. Of course, you can't do this beyond a certain level because it's not that easy to find of one character, kind, to find a lot of super talented people. At some point, you will have exhausted the available pool that you have in Munich, even if it's a big city with a lot of very good education. But I think we were able to maintain this for a very long time and really build this nucleus of amazing people that really get along with each other and love working with each other.
It's a really, really interesting take on it. I think it kind of speaks to the importance of not just the hard skills, right, but the kind of softer side of things as well. And I think a lot of founders struggle with these, not just this part, but also, I mean, you're obviously, you got headquarters in the US, but also you mentioned in Munich as well. A lot of founders struggle with the cultural differences when expanding. internationally. Have you you've been talking now about the Munich office and kind of recruitment there? Have there been any kind of key lessons that you've learned about navigating these kind of complexities?
I'm smiling because I'm imagining my co-founder listening to this right now, and no, absolutely, 100%. I would lie if I would say that it was a smooth ride. I mean, we always kept things civil and kind and whatnot, but working with how do I state this politically correctly? You basically have a partially back then, 28-year-old AI developer who maybe just had one job, or even 25-year-olds, 24-year-olds AI developers in Munich with a German culture in a completely different time zone, and then they have to work with someone who's 9 hours behind, has gone through decades of a career already, and come from a rather North American culture and so on. Of course, on a superficial level, yes, we were polite always, of course, right? It's not like we were fighting with each other all the time, not at all, actually, but still, and not just that, right? If both of them would have been AI developers or both of them would have been chip developers, that would still make things more easily. But I think also the fact that the engineering disciplines of AI, which in its software world is very forgiving for mistakes, and then chip design, which is absolutely not forgiving in terms of mistakes, because if you do a mistake in chip design, it can cost you millions and millions. Bringing all of this together, I think it's a challenge that never stops. And so it was certainly a challenge. If you ask me how did we overcome that, I think the boring answer to that is time. Time, basically lets people grow together and kind of converge in how they communicate and so on. And that really helped. There's a few other things that, of course, one can do to bridge cultural gaps, but I think it's just time and respect, right? Like, you need to basically hire people in both cultural camps who have basic human decency, let's say, right? Who are not super aggressive people or so, right? Who let other people finish and things like that, right? Basic stuff, and then I think you can grow together.
And as a co-founder, but also in your role as VP of AI and product, you're obviously balancing or needing to balance deep technical work, but also with strategic decision making there for the company. How do you manage both while keeping a clear focus on the long term vision, the big picture perspective?
Yeah. So what I have to say there is, for the first 6 years or so, I was actually leading AI development, so pretty much pure engineering. I did actually, over the last 12, maybe 18 months, I did transition out of engineering into product purely. So my very up-to-date title is actually VP of products, not anymore AI and products, although, of course, still with a huge AI focus, of course. But there was basically an overlap time where it was both. And also from a personality point of view, and also because I'm a founder and just how I work, and also I do like also building relationships with customers. So I was also very exposed to the customer side of things, also investor side of things sometimes. So, wearing many different hats, I have always been also very interested in strategic and product decisions in the company, and then try to contribute to that as much as I could. It's not easy to balance that. Absolutely not. I think every engineer on the planet who at some point leaves engineering will know exactly what I talk about when I say, you miss it, you miss writing code for the first many years for the first years of that transition. Even if you're just transitioning from engineering individual contributor to engineering manager, you will feel like writing emails and having meetings is not actual real work. It somehow feels too easy, too fake, because it's not actually writing code and actually, working through something very complex and so on. So I think by now I'm out of the weeds, and I'm definitely now on the other side, the product side, and I've fully arrived. I used to lead 25 people. Now I have a team of one. I have one product manager, soon maybe two, but that's about it. So yeah, it's been a big transition. I think what made me the best product thinking person and strategic person in the company was, however, the fact that I was so deeply exposed to engineering for such a long time, right? Because I know, as a product person, I think one of the most important things is to have empathy for the hardship of engineers, like for how complex it is to work through something, but also to know how possible things actually are if you do push yourself a little bit. That's definitely not to be forgot, right? Because there's some product people who will also always just cave when engineering tells them very strongly, oh, this is not going to be possible, right? This is going to take way more time. If you were an engineer yourself, you're going to have the confidence to say, no, dude, I know exactly that, yes, this is complex, and yes, it's going to take, a couple of days and weeks maybe to grind through this, but it's actually possible. And so empathy for the other discipline is extremely important, right? And now I also have much more respect for the product side of things, to be honest. As an engineer growing up, everything that was not engineering, I belittled it sometimes a little bit in my mind. I think it's also something that a lot of engineers do, because you somewhat even get taught to do that in university. But yeah, that was kind of my transition, I think. But now I think I've arrived in a product role. And yeah, it feels good. Yeah,
it's a really good point as well about having that engineering background, kind of, for want of a better word, kind of augmenting you in that position in product as well. I think it's a lot of companies have that situation where there's that kind of mismatch, or not disconnect, but you know what I mean, between the kind of the product manager on one side and the engineers telling them something else, and they're maybe not kind of fully believing each other or whatever it might be. So yeah, I can.
Yeah, and then it feels a little bit like enemies, right? And that's really not good. That's actually, I think it's often underestimated how destructive that is. Yeah, and the best thing for a very engineering focused company like us, I think, is to have product managers who, really find that good balance between pushing engineering but also being empathetic.
No, yeah, it's such a a deeply technical product or service at a company that you have, so it can only be beneficial, of course. Quite a generic question now, but one I wanted to kind of give you as well is really just how the company, how you stay ahead of the curve in such, like, this is a really fast moving space, right? AI and hardware innovations evolving at a crazy pace. So how do you guys stay ahead? Research and development department or.
So, I mean, by now we have reached a size and kind of a public connection to to the outside world that a lot of the new stuff happening is brought to us, right? Like somehow you read about it, somehow one person in the company at least is going to be subscribed to any AI newsletter that exists, right? We always have at least two people going to major conferences where we read about and hear about the competition. We pay money for certain really high-end reports on our space. So it's not that hard to understand what's going on. I mean, very often, for example, when DeepSeek happened, I woke up to two investors immediately asking me, "Hey, what is this going to mean?" So you're kind of forced to stay up to date.
Were they freaking out, or?
I mean, I think in the very first days, it was hard not to freak out. If you looked at how the stock market reacted, right? You had to freak out a little bit to just pay the respect to the situation. But I think the DeepSeek stuff was massively overrated. I think now most people have realized that it was basically offered at a huge loss initially. It was not that cheap, and it was also not that cheap to train it. But that's another topic that we can go into in a few minutes if you want. But yeah, staying up to date is we're generally very research focused as a company, not in the academic sense, but in the product focused research, right? I would call it research because research to me is when you do things that no one else has done before, and you also have that feeling of, I don't know for sure whether this is actually going to work, right? And that for sure is something we did. So I would say, yes, it's research, it's engineering, but definitely, we have very awake eyes and ears to look at what's going on in the world. Yeah.
And well, I mentioned earlier autonomous vehicles being kind of one industry, but what other kind of industries or applications do you see benefiting from recognized technology?
So we're not focused on autonomous driving at all anymore. This was just an initial focus. Now we're 100% focused on the data center space. I mean, the data center space itself is pretty huge, especially if you take into account that solutions that are as power efficient and dense as ours, for example, not requiring liquid cooling. We don't require liquid cooling. So a smaller form factor solution of our compute technology could also be used for on-premise deployments. It could be used for smaller modular data centers. It could still be used by huge data centers. So anything in between is possible. I mean, almost any, it could be an AI call center, it could be education, it could be just generating images for a certain service that people pay a monthly subscription fee to. The possibilities are endless. The industries that benefit from this are endless. Generally speaking, of course, you also have other, let's say, more edge cases, edge as in physically at the edge, such as drones and defense and still autonomous driving, of course, which has of course gone down a lot in prominence and hype. It's almost endless. I mean, research in general will benefit more and more from AI as well. Pharma, I think, was going to be a big thing.
And I think, well, obviously, like the world's obviously rapidly adapting AI across so many industries, all industries. What do you see as the most transformative AI-driven innovations in the next 5 to 10 years? You mentioned a few industries there, but what do you maybe see as the most transformative AI-driven innovations across them?
Yeah, the time frame you mentioned is a little bit tricky for me. If you would have said 20 years, I think my answer would have been easier. 5 to 10 years is especially at the lower end, 5 years. I think what's really going to take off in the next 5 years is agents in the digital worker world. So white collar workers, right, that are mostly doing their stuff in a browser or maybe a few other programs. I mean, you can almost do, there's a lot of people out there that can literally do their entire job through one browser, right? Because they have their email there. They might even have Microsoft SharePoint, PowerPoint, Word, everything there, right? Excel. And so, I don't want to say replacing these people, but if we're honest, right, I mean, it's kind of a replacing in some sense. And to really automate such work, I think that's going to be the big thing in the next 5 years. In the next 10 years, I think we're going to see more and more ad hoc, real-time, individualized generated media. So instead of going on Spotify and saying, Spotify is an easy case because it's just audio. It's very low in compute, very low in bandwidth. But instead of saying, "Hey, what's the newest album from Drake?" Maybe Spotify is going to generate an album for you that sounds exactly like the stuff you like from Drake, but it's going to have some elements that maximally touch you emotionally because somehow Spotify knows that you just went through a breakup, and then it's going to do exactly that kind of thing and talk about these kind of elements. And that's not very unrealistic, right? We already have the language models today that can write such lyrics. 100%. We can generate through TTS, text to speech. We can generate realistic voices and music. Yeah, I think it's mostly figured out. Maybe that's even still going to be in the next 5-year bucket. But where it's really going to be in the next 10 years, I think, is going to be today when you go on YouTube, right, and you search for a chocolate chip cookie recipe. You're going to find a couple of results, right? And then you're probably going to click on one of the first 3. And that's mostly how searching in general works for most people these days. What could happen in the future is that when you type that in real time, a video is going to be generated for you where your favorite actor is baking cookies in exactly like with exactly your oven model and your kitchen appliances that somehow, it maybe knows because let's say Amazon acquired Google by that time and they know exactly what you ordered. Um, and it's gonna be also in your language. It's gonna only use ingredients like, for example, in Germany we don't really have self-raising flour, right? Then it's probably going to use non-self-raising flour and just tell you to add a little bit of baking powder into it, right? Like, so it's going to be very individualized. But basically, every search on YouTube is going to turn into a new video that gets created. Every search. And that, I think, is a level we might reach in 10 years because it's a lot of compute that's going to have to happen. And we can't handle the power consumption that comes with it these days. And we don't have the compute for it. Yeah.
That's what Recognize is going to help with, right?
Yeah, absolutely. Yeah. Probably not the next generation, but the next generation. Yeah, we'll stay at it. Yeah.
You mentioned 5 to 10 being hard. You said you'd know what you'd say if it was next 20 years. What was that?
So I think in 20 years, I wouldn't be surprised if we just have a constant companion, basically, like an AI companion that can educate us, that can take us through hard times, that can do therapy on us or in mental coaching. And I mean, it's going to be a wild world out there, right? Like, there's probably going to be friendship there. It's probably going to go further than friendship. That might be romance. It might, hopefully not. It will bring even more people into solitude, like being isolated from the real world. But who's to also judge, whether maybe that is going to be the real world then, right? I mean, is this the real world right now? I would say yes, even if it's a video call, right? So that's going to be wild. But I think, that's going to probably happen in the next 20 years.
Yeah, no, I think there's really, really interesting points. Scary to a degree, right?
Yeah, it is scary.
But I think really, really exciting. I'm also interested to see kind of advancements in healthcare. These robotic and AI-driven robotic surgery, the diagnostic systems, and
new drugs, better drugs, more individualized drugs. Absolutely.
Exactly.
Right. Yeah.
And also a question about AI hardware and how it's becoming increasingly specialized. Do you think we're moving towards like a future where AI chips are customized for these specific use cases rather than for general purpose computing? What's your take on these?
So we're definitely already deep into the phase where people develop AI chips, chips just for AI, and not just that, but also for parts of AI, as in chips that are better for training and chips that are better for inference. And then even within the inference space, there's a few exotic companies out there. I'm not the biggest fan of their approach, to be honest, personally speaking. But Etched AI, for example, has developed a chip that is just focused on transformers. I think it's a bit of a dangerous bet because you never know when the next big architecture comes along. And so far, the biggest advancements in AI have always come from changes in the architecture, which would kind of motivate that a lot of people are doing research on the next big architecture, because that might bring the biggest push, right? So, but that's happening. And people are also developing chips for the data center versus for drones, for example, right? Or like edge applications. So really low power, sub 5 watts, maybe even sub 1 watt, maybe even lower than that. And then, rather the kind of chips that we're also developing where you're in the hundreds of watts per chip. I think it's in the near future. I don't think it's likely to go further than this, because AI also always has this nature to it. You never know what's going to happen next, right? It's very especially in chip development. If today you and I decide to develop a new chip and we have 100 engineers behind us, or 1,000 engineers behind us, and $100 million or $200 million, it would still take us probably 2 to 3 years to get the chip out, like fully out. Product is launched, production is up, and it's working, right? Like at least 2 years. I mean, some companies can be quicker than that and this and that, but let's say 2 years, right? Who knows what's going to happen with AI in 2 years? It's really hard to predict.
Exactly.
So people are very motivated to develop anti-fragile compute architectures that, in the event of a new architecture coming along that you didn't predict, it can still perform fairly well. but it's a balance, right? Because especially as a startup, you want to do something differently than like we want to be a little bit different from NVIDIA, let's say, right? And so we can't just do the same stuff that they're doing, right? They're very agnostic, right? They can do everything. They can do gaming, AI training, AI inference. They can do everything on their chip. And that's why people also kind of love them, right? Because of that flexibility. We as a startup, we have to focus on a certain purpose, right? Like it needs to be purpose built, and we need to really excel in something that's a big enough market, but we specialized it for that. So I don't see it going further than what we're already seeing today. But from a generally speaking chip design point of view, I do see some changes. Memory and networking are becoming increasingly important and also bottlenecks. So memory, DeepSeek R1 was praised and celebrated as a hyper efficient model. It's actually a giant model. It has 671 billion parameters. That's like 4 times the size of the initial GPT model when ChatGPT came out. It's 1.5 times bigger, even more than 1.5 times bigger than the biggest open source model that we knew until then, which was Llama 405B by Meta. So it's actually a giant model. It's just that it doesn't use all the parameters every time it predicts a token. Okay, fine, which has some other issues then, but that's something we can talk about another day. But the models are becoming huge, so you need to have a lot of memory, and the memory needs to be very close to the chip. And so either it's on-chip memory, which is, for example, what companies like Grok do, or Cerebras, or it's memory that is still very, very close to the chip and still thereby very fast. It's called HBM, which is what companies like NVIDIA, AMD, and we are doing. And that's the slightly more pricier version of it, but it also allows you to have literally around 1,000 times more memory per chip than if it was on-chip memory. And that's a really good fit.
Why then? Just to kind of on that topic, why then do companies like Grok have the kind of on-chip method?
Grok's chip that they're currently deploying was developed before Gen AI happened. The chip was not specifically designed for Gen AI. It was renamed from something previous to, I think, LPU, language processing unit. Obviously, as every company, everybody's working on their next thing, right? So let's see what's going to come out at some point. But a lot of these chips that are being, sold as tailor-made for Gen AI, they were actually developed before it happened. So as our first chip was, right? Like our first chip was also focused on convolutional neural networks and not at all transformers or Gen AI. So as I said, right, it's hard to predict, but this is also why the generation we're now almost done developing, that one is definitely much more on the anti-fragile side, where nothing can surprise us. Like we're going to be able to compute pretty much everything, and we'd rather focus on other innovations that are so agnostic by nature, like log math and really good networking and good data path design, so that the compute part of it and the architecture part of the AI model doesn't play such a big role.
And you've mentioned a couple of times as well these kind of edge devices, drones, for example, and I'd like. Where do you stand on steps forward or leaps forward really when it comes to advancements in edge computing rather than cloud-based models as well?
Sorry, are you asking where the difference lies between the two?
And also how you see kind of advancements in both.
I think the advancements are definitely happening in both worlds, at a, I would say, fairly equal pace. The thing is that an edge AI compute chip is a little bit like a miniature version of a data center chip. There are, of course, different interfaces. The data path design will look a little bit different. But in terms of just the compute, I think it's very similar. Yeah? The memory technology might also differ a little bit, but my point is, whatever innovations people come up with for an edge or data center AI chip, very often these innovations might actually also be beneficial for the other domain. So I think the pace of innovation seems very equal to me. I think lately there's been a lot of investment focus on data center and not as much on edge. But actually, one thing that is more specific to edge is that there's a couple of startups and companies focusing on analog approaches or neuromorphic AI chips, where you basically leverage analog physics. So you basically leverage physics to compute math. And so it becomes an instant thing, or at light speed almost. It's a much more complex technology to handle, but wherever power consumption matters a lot, I think it has some right to exist. Yeah, that's one trend that I'm seeing. But then again, it's also more fragile to changing environmental conditions like temperature and so on. So, yeah.
And as we start to wrap up a little bit here, I'd love to get some lessons from you on the startup journey. Obviously, founding deep tech AI startup like Recogni, it's a massive undertaking. But what's been the most rewarding part of your journey so far?
Oh, I think when you hear a compliment from a colleague that you've worked alongside with for years and years, and then suddenly after years they tell you something that you did great. I don't know, that feels very special to me, because suddenly you feel seen for what you did, right? And especially if the compliment is like, if I can like very much connect and resonate with that compliment, and I know it to be somewhat true, that's these are the most powerful moments. Otherwise, I mean, incredibly happy moments were, when we got our first big financing round. I will never forget how that felt. It felt amazing. How for the first time, when I was still an individual contributor at Recogni, our initial compression scheme. The first time I refreshed the results page and I saw that it worked for the first time. Well, I will never forget that moment. It felt literally like an episode out of Silicon Valley, the show. And these are incredible moments. Of course, as the company gets bigger and older, these very spiky moments, they become a little less, right? They get flattened out. I mean, it's also just a career progression for myself, and a learning progression and a development also as a person that I was very thankful to have throughout all of this.
Really nice mentions there. But if you could go back to when you first started Recogni, what advice would you give to your younger self? I know you're 7.5 years ago, not that long ago, but what would you maybe do differently, let's say?
I think the biggest thing I would tell myself is be a little bit more resilient. Don't take everything so personally on like an emotional level, because it really was like an emotional roller coaster ride in the beginning. When an investor told us, sorry, I'm not going to invest, right? That almost felt like a mini breakup every time. Definitely not the case anymore today. And if I ever start another company, it will also definitely not be the case anymore. I was very young, and that's how it was. But honestly, maybe it was also good that it was this way, because there's also a lot of energy behind that emotional involvement.
Yeah, I think it's completely natural to a certain extent, right?
But at least, don't take it personally that much. Don't be a little bit more resilient, and just trust yourself that you know what to do, and stay humble and all these things.
Nice. And lastly, what do you think is the biggest misconception that people have about launching a tech company?
It's a good question. I don't know if I can see camps of misconceptions. I don't think there's one misconception that most people have, but there's definitely a camp that thinks, and I have been guilty of that myself at some point once. I'm just going to sit down with a friend for a couple of months. We're going to ideate. We're going to come up with a good idea. And then we're just going to go out and raise, $100 million. Even when you read about these massive funding rounds that are happening for AI startups right now, very often, if you know the founders who raised that money, it wasn't that easy, right? It was a tough time, and it's never easy. It's really, really never easy. But on the other hand, another misconception might also be, definitely go for it. Definitely do it as long as you're also still young enough, I would say, and you don't have, like a very expensive lifestyle, you don't have a family and all. Really try to do it, because I think founding a tech startup these days, the upsides are absolutely outweighing the downsides. I can see very little reason for not doing it, except for if you really want to excel as an individual contributor, like a programmer, right, like a developer. Then, of course, becoming a founder might not be the best thing to do, because it will distract you from actually doing technical work. At some point, you're going to have to be a manager of some kind. Yep. You're going to have to wear many hats. So maybe then it is actually a good idea to stay in big companies that are working on things of massive scale, massive impact. Maybe also work at a startup at some point, but try to not be a founder. But otherwise, I think, being a founder is a tremendous experience, and really teaches you a lot.
Yeah, no, I can agree. And specifically about the kind of, wearing or donning a million hats during that journey, right? But brilliant. Is there anything you'd like to add before I wrap up here?
Not really. I think we touched so many different interesting points. No, thanks a lot. This was actually, I think, maybe the most pleasant podcast I ever was part of. Really good questions. Very pleasant talk. Thank you so much. Yeah.
No, really, really nice of you to join us, and shared some really, incredible, really interesting insights. And great groundbreaking work that's going on in this kind of energy efficient AI.
Thanks.
And it was really nice to get your thoughts on the kind of building and leading a global team as well. So a lot of fascinating ground covered. So thanks so much for joining us. And for our listeners, if you want to learn more about Recognize, please visit their website, recognize.com. And that's all for today's episode of Builders. Don't forget to follow us for more conversations with leaders like Gilles, shaping the future of technology. Until next time, keep building, and we'll see you soon.